All right, let's go through the next of steps, which is we are creating another table called sec filing index. Now I had previously created it, so I'm gonna just to create or replace. All right, there is another table we are creating which is sec filings attributes. So one has index data, the other has attributes data, and you will notice we are using only one column called V, and the data type is variant. This is so that we can load semi-structured data from JSON files into this table. Now for the JSON files, we have another stage location, but this time instead of using a UI, I'm gonna use the SQL here. And I have now the stage location which is pointing to the public bucket which Snowflake has provided as part of this quick start. When I run this list command, I can see what files are inside that stage. So there are two json.gzip files. Also, you'll notice that Snowflake can automatically uncompress the gzip files and load the JSON into the table. So we are going to run this copy command to load index data into this table via this JSON file. Yeah. So we are specifying the path of the file itself. So the stage location / the file name. So Snowflake is going to read only this file and load it into the particular table. Next thing, we are going to do the same thing for the second table in variant column. So this time I have attribute JSON file and data getting loaded into the other Snowflake table. This command is gonna take some time. By the time, let me show you the copy into statement format in Snowflake. So if you click on this data loading aspect, you will find how do you load data using the web interface, and then bulk loading under Amazon S3, creating the S3 stage which we just did, and copying data from S3 stage, right? So you will find this copy into statement, and you will find the syntax for copy into and what all options are there. Yeah. All right. So our data has been loaded from JSON file into this particular table. This one had more amount of data, so it took longer. Let's see how the data looks like, right? So this is our index table. This was the JSON file, and you will notice that it is the key value pair kind of structure. That's how the data is typically stored in JSON file. So when we loaded this data into Snowflake table in variant column, it is still visible in the same raw native format, right? So we can essentially work on this raw JSON format. The benefit is that as the incoming data fields are changing, we don't have to change our table structure. The same semi-structured data format can get loaded as it is. This is very useful in having dynamic fields getting captured. And this is the other table. You will see that it's the same kind of key value pair structure here. Now on top of this security filings index table, I'm going to create a view, and inside the view, if you notice here, I'm doing a dot notation. So it's a column the data, the column name, and then the particular key name which I am extracting from this. So it's a way of reading this JSON data in a structured form. You can also call it schema on read approach, right? And when I query this view, the data will come out in a structured format. This is another view I'm creating on the other table. So if I look at the data in this view by firing the select statement, you now see that this data looks much more structured, right? So earlier when I ran a select star on the table, you were seeing the key value pairs. But when I ran the select star on this view, it's giving me data in the structured form because we have defined these columns as the variant column, the key name, and hence it is giving me output in this particular structured format. So it's a way of creating schema on read. From the underlying semi-structured data, we are getting a structured output. Of course, if you wanted to materialize and write this data into a separate table, instead of creating a standard view, you could have also created a table and then loaded data into that. All right, now we will create another virtual warehouse to do rest of the lab, just to show you that you can have multiple warehouses operating on the same data. And how do you create this warehouse? Via SQL, right? So this is a SQL command: create or replace warehouse, name of the warehouse, the size, properties of auto resume, auto suspend, and so on. Of course, UI makes it much simpler, but once you get a hang of SQL and you know the parameters, you can very well make use of SQL as well to create the warehouse. And now we are going to say use warehouse analytics warehouse, so that rest of the commands are running on that particular virtual warehouse, right? So the idea is, if I have multiple workloads, for example, analysts firing their queries, they can make use of a different virtual warehouse compared to the data engineers who are running their commands on a different virtual warehouse. So far all this work we did using compute underscore WH, and now we are doing the work using analytics underscore WH, right? So different people can use different warehouses. I mean, I am a same user, but in real life you will have different users having different Snowflake interface, having different worksheets or tools. So some of them will make use of this warehouse, some of them will make use of compute underscore WH, and so on. So that allows you to separate the workloads on different virtual warehouses. So just doing a select star on this structure table which we had created. Now you can also perform joins between the tables like any other database. So we are doing an inner join here between the two tables.